Good evening, boys and girls. Day 3, coronavirus. So I got a couple things we're going to go over before we start the lesson. We're not going to get into the lesson just yet. I got a couple questions from today's homework. As you know, I filmed this the night before the intended lesson. So I'll also try to make this lesson a little more real for you because I got some notes that this doesn't seem like a real lesson because, I'm not teasing some of you or going off. So I'll do my best to improv how I would act, ways through this lesson to make it feel like it's a real lesson taught by yours truly. So first, I'm going to answer some questions about specifically numbers 20 through 30 on quadratic, on factoring bigger numbers from quadratic expressions. So I'll start with this one, 49 a squared minus 70a plus 25. Close your Chromebooks. I know what you're doing. So first things first, when you got a big number like this happens to be a perfect one because we got two perfect squares. In this case, because this is positive, this is negative, this tells me right away this is easy because square root of this is 7, square root of this is 25. Again, be aware and vigilant knowing that this is positive, this is negative. This has to factor down into 7a minus 5 and 7a plus 5. All right? Now, this will get easier the more practice we do with this. So just give it time. It'll just come more naturally. We're breaking this trinomial into two binomials as such. So now I know when I use FOIL, 7a times 7a is 49a squared. This is positive 35a. Oops, I made a mistake. That's rare. I never make mistakes. Haha, you see what I did there? So it's negative 35a. I caught my mistake because I know that I would have canceled off the middle term by having a positive and then a negative. That would have left me with no middle term. So in this case, this is correct because I get positive 45, negative 35, another negative 35, 35 plus 35, negative 35 plus negative 35 is negative 70. Hence, negative 5 times negative 5 is positive 25. So that handles something like that. Another one is going to be 9k squared minus 1. Also, this is a difference of squares. This happens to be nice because my coefficient's 9. Square root of that is 3. Square root of 1 is 1. So this happens to be, because it's negative, there's no middle term. This is 3k plus 1, 3k minus 1. So when you do this, stop talking. Stop talking back there. I see you talking. All right? So now I got 9k squared, negative 3k, positive 3, cancels the middle term. Negative times positive is negative 1. So there's that. Another example is going to be, give me a second. Uh, 12k squared. I'm sorry, 12x squared plus 12x plus 3. Now, this one's kind of hard because you don't know what factors to break the front one into, but I do know based on this 3, which is a prime number, my last numbers, when I set this up, my thinking is broken down like this. I see positive, positive, this has to be plus, plus, okay? Now, because this happens to be a 3, it's a prime number, I can put the 3 here or the 1 here, it doesn't matter. Now I gotta figure out what goes here. And this is again why I use pencil, because you're gonna make mistakes. I'm just gonna check out, I'm gonna do 4x and 3x. I'm gonna see if this works. I get 12x squared, not a problem. I'm breaking down this into factors of what factors break this down. So in my head, I'm doing 4 and 3 first, checking this out. 4 plus 9 is 13, so that's not going to work. So these are not good factors. Maybe I'm going to change it up and do this instead. Again, I'm just checking this out. I don't know. So I got 3 plus 12, that's 15. That's no good. All right, so now I'm going to check another factor. I'm going to do 6 and 2, okay? 12 right there. That's going to be a problem because I'm going to have, I'm sorry, I have 12x, I'm sorry. 12x squared takes care of this, all right? 12x squared. This is plus 6x plus 6x. Boom, there we go, I got my 12. So there are my factors. So here are my factors of this. And then one more for you guys, just to help you think through some more of these. This one's a little harder, takes a little more time. Again, you're just always breaking down factors, hence why it's important to know your multiplication facts. 54x squared plus 72x plus 24. Now, before I started this video, I tried it on my own, and this was my first. Quiet down! I said stop talking while I'm doing this. Knock off the talking. I'm trying to teach you something. Keep it shut it. All right. We got this right here. I tried this out first. 9x plus 8 and 6x plus 3. This is my first trial and error. I'm only trying these factors of 54 because this middle term 72. I'm not going to try something larger than that, and I'm just going to try out my easy factors first and go from there, which I encourage you guys to try as well. So as I do this, I know this makes 54x squared, not an issue. I got 27 plus 48. 27x plus 48x. So I'm going to get x carry the 1, 75x. I'm close, but I'm not close enough, so I got to get that middle term to 72. So I'm going to try something different. Instead, I'm going to try some other factors of 24, such as 6 and 4. And I'm going to do 9x plus 6, 6x plus 4. Again, I'm paying attention to my last term multiplies to this, and then this is where I did the trial and error. I already know this makes 54. I got 36x plus this right here, 36x, so boom, I found my factors, and I figured this out. Again, this is trial and error. You'll see the purpose of all of this factoring as we go through this, and the more you do, the easier this gets, all right? The last question that I had from yesterday, I'm talking in Twilight Zone because I'm doing this the day that you guys asked me questions, so I'm trying to make it seem like this was whatever, just pay attention. Factoring by grouping. So this can be kind of confusing, and I understand you guys. We've got some questions around this with Khan Academy. So I got 4x squared plus 25x minus 21. So this can be kind of confusing, but I'm going to try to break it down as easy as I possibly can. So if I got this example, the way I want to think about this is my A times my B has to be equal to my 4 times my negative 21, which happens to be negative 84. Okay? I also know that my A plus my B has to be equal to my 4 plus, it has to be equal to this number right here, the 25. So that takes care of that. Now, how do I go about breaking this down? Couple ways. I'm going to look at this and I'm going to play with my factors of negative 84. I'm going to focus on just this like I always have, my product, okay? So I know my negative 84. I can, trial and error a couple of these, and I'm just going to do this in my head. I know 184 or negative 1, negative 84. The difference of these two factors is not going to add up to 25, no matter which one's negative or positive, so forget that. I'm going to try another factor such as 2 and 42, or 2 and negative 42. Again, my difference of the two of these doesn't make a difference because I'm going to be too far away to add up to 25. And now I'm going to try my next factor, which happens to be, I'm going to try 3. 84 divided by 3 is 2, 6, 4, 2, 8. So I think this might work if I make one of these negative. So clearly if 3 is negative, 3 plus 28 is 25. I'm sorry, negative 3 plus 28 is 25, and negative 3 times 28, it makes negative 84. So this looks to be my factor. So now, how am I going to break this out? So I got two different factors I'm going to use. I got my 4x squared plus 28x minus 3x minus 21. Now, why did I write it in the order I did? Because I was looking at both of these numbers and I thought, which one of these two numbers has something in common with 4? And I know 28 does. That's why I factored by grouping. And I'm putting this with this on purpose, and this is how this works out. Now again, this is just for practice what we're doing. When we're solving quadratics, we're rarely going to use this, but sometimes it just helps speed up for efficiency purposes. So I put this with the 4 and the negative 3 with the negative 21 because when I group them, these both have a common factor of 7x. I'm sorry, my apologies. 4x, all right? 4x can divide out of both of these, so I'm gonna have x plus 7, and what factors out of both of these? That's right, a negative 3. Negative 3 is left with x plus 7. Now hopefully you notice something. I got two parentheses that are identical, hence factoring by grouping. So here's how I factor by grouping. I got my 4x minus 3, that's one parentheses, and I just take one of these because when I take these and I use FOIL, 4x times x is 4x squared. 4x times 7 is 28x. Negative 3 times x is negative 3x. 28 minus 3x is positive 25x, and this makes negative 21. That is one way to factor by grouping. So give it your best shot on Khan Academy. Again, it's just another way to factor. It sometimes helps out with these big numbers, but again, we're just practicing with some of this stuff. So I'm not going to give this that much focus right now, but when we get back in class, I promise to go over this a little more in depth. Now, why is all of this important? Because we are going to focus on domain and range going forward. Today we're just focusing on domain, and just so you guys know what the whole purpose of this is, when we're doing this, your domain is always your x, your range is always your y. Or another way to think about it is, this is your input, this is your output, okay? Thing you put into the question to see what your answer is, all right? So we're gonna practice the heck out of this these next couple of days, and then we'll go into the book work just to have all this make sense. So specifically today, we're going to focus on only domain. We'll start off easy. For instance, I got a function such as f of x equals 2x plus 5. Well, in this case, the whole point of domain is to know what rules you're bound by. In this case, this is just a linear function. I have 0 rules, therefore I can input anything for x and get any possible answer. Now remember, negative answers and positive answers are valid for this particular situation. So this domain is considered all real numbers. All negative numbers, all positive numbers will give me a valid answer. Even 0 will give me a valid answer. If x is 0, the answer is 5. If x is negative 4, the answer is 1. If x is 4, the answer is 9. Get the point? This is bound by no rules. This is an all real number situation. Now let's make it trickier. Now let's say I got a function like this, and I have, again, we're getting easier. We're going to start easy, get hard, but if I got a situation like x squared minus 6x. Now, in this particular situation, I got a radical, square root. So it is impossible for me to take the square root of a negative number because no such number exists. So in this particular case, again, I'm starting easy, getting hard. This is also another all real number situation. This is an all real numbers is my domain. Because, think about it, if x is any number negative or positive right here, right? Anything squared is going to be positive. So 7 squared is 49, right? 49 minus 7 squared, well 7, which is 42. 49 minus 42 is 5. I don't know, I think we still have to answer that, but whatever. It's late at night and I'm tired. Again, if x is a negative number, negative 7 squared plus 42, use mental math, this is a situation where you can have any real numbers. And 0 is also a valid answer because the square root of 0 is 0, and that's valid in this situation. Now let's get a little trickier, all right? Remember these rules. Come back to this part of the video if you forget, because there's a lot of different rules, a lot of different situations. So now I'm going to start getting harder. F of x equals the square root of x plus 5, okay? Now we know that it's impossible for this situation to have anything less than 0. So in order for this answer to have a domain of anything less than 0, x has to be greater than or equal to negative 5. Okay? Because, again, mental math. Negative 5 plus 5 is 0. Negative 4 plus 5 is 1. Negative 3 plus 5 is 2. Square root of 2 is square root of 3 is a real number. Totally fine. But if I were to put negative 6 in here, negative 6 plus 5 is negative 1. Square root of negative 1 doesn't exist because there's no number times itself that equals negative 1. So your domain is listed like this with those inequalities that we just finished learning. And it's imperative that you recognize that this domain is x is greater than or equal to negative 5. Quiet down in the back there. Going on, let's do some more. Here we go. Now I'm going to do some denominator functions where we are bound by a few more rules. All right. Our one rule for a domain, let's put some rules off to the side for this, okay? Domain rules. Can't have a negative in a radical and can't have a 0 in the denominator. Okay? So, in this particular case, there are two numbers that exist that x cannot equal. Okay? And I want this to be kind of mental math and just think about it. So, if I were to just break this down into factors to make my recognition a little easier, I got I got x minus 6 when I factor this out. Because I'm bound by this rule, I can't have a 0 in the denominator. X cannot equal 0, and x cannot equal 6. Cannot equal 6. Because 0 times negative 6 is 0. Just like when I put 6 in place of this, 6 minus 6 is 0. 6 times 0 is 0. Hence, those are the only two numbers that domain cannot be. So this would be considered a valid answer. That's that. Let me go on to another one. Now let's say I put a radical in the denominator. Okay? So now remember, you're bound by two rules when that happens. So let's say I have 1 over f of x equals 1 over square root of 9 minus x squared. Now, I would always recommend that when we see this, we just, for our mental capacity, we think about this as reversing it, so it's written in standard form or regular form, however you want to think of it. This would actually be the same as square root of negative x squared plus 9, because now I can break this down a little further into 1 over, factor this down. This is another perfect difference of squares. So square root of x minus, this is negative x plus 3 and negative x minus 3. Now I made a mistake there initially by starting this off because I did not make, this is again another mistake I made, we write in pencil. Negative x times x is negative x squared. This, again, another mistake. Always check your work, all right? Negative x times x is negative x squared. This is negative 3x. This is positive 3x. That middle term cancels off. This times this is positive 9, so this is all gravy. Now, here's where we're bound by some rules, and this is where we have to think a little bit, is doing this domain stuff. I know that if x is 3 in this case, this would be negative 3 plus 3 equals 0. 0 times 6 would be 0. I know that x cannot equal 3. I also know x cannot equal negative 3 because that makes this 0. However, I also know that I can have numbers between 3 and negative 3 because, pay attention to this, if x was 0, okay, if x is 0, here's my baseline, if x is 0, well, 0 plus 3 is 3, 0 plus 3 is square root of 6, square root of 9, because this would be 3 times 3, which is 9, is 3. 1 over square root of 3, 1 over square root of 9, which is 3, 1/3. Lo siento. We get a valid answer. A decimal answer is fine. I don't care if the radical produces a whole number or a decimal answer. It still counts as a real number, no matter what. However, if I were to go outside of these, if I were to go to, let's say, x equals 5, or x equals negative 7, all right, because that's beyond negative 3 to the left, and 5 is beyond 3 to the right on the number line. This is where the thinking has to take over. So if I were to put 5 in place of x, okay, negative 5 plus 3 is negative 2. Negative 2 times, again, this is 5 plus 3, which is 8. Negative 2 times 8 is negative 16. Is it possible to take the square root of negative 16? No, it's not, all right? So that's why this is not possible. And then I'm testing a number to the left of negative 3. All right, so negative 7. If I put negative 7 here, this says negative 7, which is 7. 7 plus 3 is 10. But now this says negative 7 plus 3 is negative 4. I got 10 times negative 4. And I got another negative number. So your domain for a situation like this is listed as x has to be, or better yet, I can write this a couple ways. You can just say negative 3, x is either less than, but x is also, x is greater than negative 3, but x is less than 3, okay? Or if you want to be fancy, just be my guest, I don't care. You can write, if you want, on your own, just two separate things. If that's too confusing, say x is less than, Jesus. You can say x is greater than negative 3, but x is also less than 3. I will accept either way to represent your domain for that situation. I'm going to do a couple more and then let you guys do some more to ask me questions, because I assume this is going to take a couple days to fully understand. Do some more examples. So let's say I had f of x equals 1 over negative x squared minus 4x. Okay, this is a situation where I have no radical. I'm following just I can't have a 0 in the denominator because this has no radical, so there's no zeros allowed. Make my life easier, factor this down. Did I want negative 4? I did not want negative 4, I want it to be plus 4. Doesn't make a difference if I call it the negative problem, just for the sake of this problem, just pay attention. I'm going to factor out a x. I'm going to factor out an x of both of these terms. So now I'm left with negative x plus 4, okay? I can now I can easily see, because I was factoring, which is the whole point of what we did earlier, I factored out my GCF. I can see that my only greatest common factor of both these terms happens to be x. X cannot equal 0, okay? Now pay attention, this is a negative x, all right? This doesn't mean x cannot be a negative 4, because if I input x as a negative 4, this now says negative 4, all right? X can also not equal 4, because if I input a 4 in place of x, this now says negative 4 plus 4, which is 0. Hence, this whole thing is 0. So there's my domain restrictions, all right? A couple more examples, then you'll be on your own. All right, now, sometimes I'm going to have rules to follow in both my numerator and my denominator. 1 minus x all over, square root of 1 minus x all over square root of x minus 5. So let's focus case by case, okay? In my numerator, my radical follows one rule only. My radical follows the rule that I cannot have a negative number under the radical. Impossible. So in that case, my domain for this numerator, which is the whole function still, so I'm following both rules for both x's, happens to be x has to be less than or equal to 1. Okay? Now, I'm allowed to equal 0 in the numerator. I'm not allowed to equal 0 in the denominator. But because this says minus x, and I chose this on purpose to be careful, listen. If x is less than or equal to 1, if I input a negative number for x, remember, this says negative, which is positive. So be aware. That's why I was very cognizant and aware of being aware of that situation, because you're going to see some of that in today and tomorrow's work. So that takes care of the numerator. Now my denominator follows both of these rules. All right, both rules. I can't have a negative number, nor can I have a 0. So because of that, my domain for this denominator, which again is for the whole function, x has to also be greater than 5. Okay? Because clearly, this is the only way it can work. So my only way that any number can exist, I cannot have any numbers between 0 and 5. All right? To make this work, or if I'm thinking whole numbers, because that would make both cases true. All right, guys? I'm not going to go into much detail there, but on the next one, here's why we've been doing all this factoring of trinomials. All right, trial and error for tonight's work. So now let's say I have this function. F of x equals x to the third power all over x squared minus 10x plus 24. All right, so now I'm not bound by a single rule in the numerator, so I don't care what I put in place for x to the third power, because I can put in 0, I can put in negative numbers, I can put in positive numbers. I don't care. It doesn't make a difference what I put in there, because I'm not bound by a single rule, because there's no radical and it's the numerator. All I care about is this guy down here. So how do I factor this? Again, what multiplies to this, that adds to this. So if I'm going to break this down, this now says x to the third all over x minus 6 and x minus 4. I purposefully chose to put a negative number there and a positive number there, so you know why this details are so important, because a negative times a negative is a positive. Negative plus a negative is still a negative. So my domain restrictions for this happen to be x cannot equal 6 and x cannot equal 4. Therefore, we're set, because if x is either one of these, that'll make this denominator 0. Hence, this domain for this function cannot work. So, I hope this helps you guys out. You guys are asking good questions on Classroom and sending me emails. Please keep giving me feedback about what's making sense, what's not making sense. I will go over this again tomorrow, and we'll do another worksheet with this tomorrow. So just whatever instructions I put on Classroom, follow those instructions, do what's asked of you, keep on turning stuff in. You guys are doing wonderful given all this situations. I'll try to get a little more me going forward, because I know this is probably weird without me raising my voice or getting crazy. But I'm proud of you guys. Keep up the good work, and I will be in touch. Send me emails and any questions you have. Thanks, guys.